We all know that MetPy has the ability to read METARs and get surface observations for you, but how do you know which station is the closest to a point of interest? This week we're going to look at how to use the KD tree and find the closest METAR to any point on the planet. Welcome to another MetPy Monday. Hello. I'm John Lehman, a software engineer for Unidata. This week I want to tackle a problem that I've had recently, which is I want the METAR nearest me. And there's a number of ways we could approach this, but MetPy has a nice database of station information built in that we can access, so I just need to get latitude and longitude for all those stations and compare it to my point of interest. Now, doing that with many thousands of stations on a one-by-one basis is not very efficient. And since I want to make a lot of queries, I'm going to use the KD tree structure, or a k-dimensional tree, which is a very efficient way to divide and sort through data. Now, the computer science behind the KD tree is rather complex, but the good news is that scipy has a KD tree object that we can just use, and it works quite well. So what we're going to do is, this is Tulsa Raceway Park, a place where people gather, and they might want to know what the closest weather observation to the park is. So we're going to use its coordinates and try to find the closest ob to this location. Over here in a notebook, the first thing we're going to do, of course, is import. I'm going to import pandas as PD. I'm going to import GeoPandas as GPD. From scipy.spatial, I'm going to import the KD tree. From shapely.geometry, I'm going to import the point object. And from metpy.io, I'm going to import station info. So we're going to do some additional work here to actually get what the distance to the nearest METAR is, so I know if it's a relatively close station or not. So that's why we're going to use Shapely here. Okay, so first I need to get the information of the latitude and longitude of a station associated with its station ID from MetPy's station info. So station info, we can iterate over it and get the information for each station. This is not an incredibly efficient way to do this, but we have to do this once, and then we've got our tree built, and we can do many queries against it. So this is how I decided to do it. I'm going to create a list called station rows. It's an empty list for station ID and info in station info.items. So this is going to go through that dictionary and get our station ID and the information associated with it. I'm going to try the latitude, getAttr, info, so out of our info dictionary, see if latitude is there. If not, it's going to be a none. Info, longitude, and none. And this is just so if there's anything that has no latitude or longitude information with it, we're going to ignore it. I don't want to try to build a tree around it and search if I don't know the location of the station. So if lat is not none and lon is not none, then we're ready to append the information to our station rows. So that's station rows.append. And I'm going to append a dictionary with station ID as the key for the identifier of the station, lat for the latitude, and you guessed it, lon for the longitude. And we'll go ahead and close our bracket and parenthesis there. Since I do have a try block, I'm going to put an except block in, and I'm going to catch any exception as E. We're just going to continue, go to the next item in our loop. Finally, we want to make that a data frame. So the data frame is going to be pandas, going to create an instance of the data frame object using our station rows list, and pandas knows what to do from there. Oh, we forgot our colon there. Okay, and we're done. If we look at that data frame to see, did we get what we want? We sure did. So there's almost 14,000 rows here with a station ID, a latitude, and a longitude value. Great, so now we're ready to get to work on our tree. I'm going to get the coordinates of each station just by accessing lat and lon.values. And I'm going to feed that to the KDTree object and store the result as tree. So now we've built our KDTree. So our target lat lon, we're going to get that from Google Earth here. I'm going to right click on the speedway and say copy coordinates. And I'm going to paste those in here as a tuple. I need to remove west, make that minus, remove degrees north, and put a comma there. So now I have the latitude and longitude in degrees. Okay, so I'm going to get the distance in degrees, which is the distance on our KDTree, and the index of the closest station to our target by using tree.query on our target lat lon. That means the nearest station to me is going to be using iloc, our index location, on our data frame. That's going to show me what the station row is. So if I look at the result there, I get this one row of our data frame telling us that KTUL is the nearest, and there's its lat and lon. But we can do better than that. Let's go ahead and try to compute an approximate distance. I'm not going to get crazy here with trying to get meter accurate, but we're going to just use the 3857 reference frame, which is a modified Mercator like you see in many web maps, and it has units of meters. So we're going to take our lat lon or plat Curie, project it into the 3857 coordinate reference system, and then we can do just simple math there to get the distance in kilometers. All right, so we're going to get the station coordinates, and that is going to be our nearest station lat, comma, nearest station lon. So now we have target lat lon, station coordinates. And we'll close that paren there. So now I'm going to create a geoseries for the target and the location, or sorry, for the target and the station. And we're going to do that just so we can use some GeoPandas features like projection. So our target geometry, geopandas.geoseries, and it's going to be a list of just one thing. That one thing is going to be an instance of point, which is target lat lon, and we want the first element because we use x first, or longitude. Target lat lon 0 for our latitude. Close the paren for point, and close our list of one item. Then we need to specify the coordinate reference system. In this case, it's EPSG 4326. Okay, now I'm going to copy and paste that, change it to our station, and target lat lon is going to change to station coord. Okay, now we have our two geoseries created. We want to convert them to the projected 3857 CRS so we can get things in meters. So our target projected is our target geometry .2CRS. EPSG is going to be equal to 3857. Going to copy and paste that. Station projected is going to be our station geometry to the same coordinate reference system. Finally, we're ready to calculate the distance in kilometers. Our projected target, we want the distance to our station projected. And we're going to take that and divide it by 1,000 to get that answer in kilometers. So finally, we're ready to print out our results. So our target location is going to be our target lat lon, and we want to make that an F string. Our nearest station is going to be the nearest station's station ID. And because we're using single quotes inside, we're going to need to use bad quotes on the outside. Okay, so that's working. We've got our target location and the nearest station is KTUL. We will add in that our station location is station chord, and that our distance is distance kilometers. So there we have the target location, nearest station, station location, and station distance. So that's KTUL at around 3.7 kilometers. If we go back to Google Earth and zoom out just a little bit and look over here, we can see that the Tulsa International Airport, home of the KTUL station, is indeed quite close. And using the measure tool, it's 10 to 11,000 feet, which lines up with the distance that we've calculated. So we know that our KD tree is indeed working properly. So this is a really quick way to build that KD tree once and then be able to make lots of very, very fast queries against it to find stations nearest to points of interest to you. I hope that you found this useful, and I'll see you on next week's MetPy Monday.